good? All right. Hello, everyone, and welcome to the last sessions of today. Thank you for being patient and take the time and be here today. My name is Giulio Astori. I'm a principal program product manager for Defender for Cloud. And with me, we also have James. In the next 45 minutes, I'm going to walk you guys through the modern market landscape. What are the current security challenges organizations are constantly facing in this modern marketplace? We're then going to explore solutions, the Microsoft solutions to such challenges. We're going to see some of the attack vectors, how they actually evolved. Then James will go over a demo, a really cool demo, I promise you. Then we're just going to close up with key takeaways, some recent innovations, basically, and then we're going to do just basically give you some additional resources. So without any further ado, I'd like to kick it off with the very first slide of this deck. And I need you a little bit of imagination. So let's imagine this fast-growing company racing to be the most world-class cloud organization embracing AI-based application. Leadership in this organization is eager, is very pumped up, energized to innovate and deliver fast and fast everything that can be delivered as fast as possible so they can be ahead of the curve when it comes to competitions, right? So everything is moving very quickly within these organizations. Everything is being developed at a fast pace, okay? Everything is good until, okay, alerts start piling up. They started seeing, exposed workloads, vulnerabilities into applications, vulnerability into the AI agents, so on and so forth, misconfiguration. They start seeing weaknesses. Then, at that point, the developers, the IT team, the IT operations team, the security admins, they are trying to combat every day to try to fix those missing issues, but they are coming up so much, they don't have enough manpower to do it. And then that one day, that call comes up. That one single call, and nobody wants it. The CTO gets called, or the CISO, you have been breached. Oh man, that is then where the word hand for this company, okay? So you're thinking like, oh no, this is a fiction. It's not a fiction. It is actually a true statement. Many companies nowadays are into this state. It's very common, okay? Very common into this modern, fast, environment where everything has to move so quickly to ship every new feature and even every new application, every new service that things are forgotten. The basic stuff, the basic principle of security are often forgotten, okay? Now, within this new modern environment, the actual attack surface has growing, has expanding, okay? To the point where you have more attacks and more sophisticated of those attacks. And then companies trying to mitigate that by adding always more tools. They think that adding more tools will solve most of the problem. And some company like Microsoft or other company like that says, okay, this is what's good, this is what's not. So they're adding more tools. And guess what? Those tools, most of the time, they don't even integrate each other. So what do you have? You have a tool sprawl, okay? There is the sense of having a lot of tools and none work together. Now, when it comes to attacking surface, one of the most problem is visibility. What's happening is a lot of stuff are going to be coming up and then not seeing it. So guess what? If you don't see it, you cannot fix it, correct? So that's the first thing. Visibility, the lack of visibility in the security and compliance, it's the very first challenges. Then you have the notion of the increase in the number of sophisticated techniques for those attacks, okay? The attackers now are getting very smarter, and with the AI, they're getting even more smarter, okay? To the point where a simple misconfiguration, a simple weaknesses will give them the key to your kingdom, and what's the results on that? The results said soon they're going to get in and get all the sensitive data, okay? As I say earlier, in that fiction company, everything's moving so fast in terms of development that a lot of stuff is being developed and created, okay, without this full sense of security, okay? And that creates an expanded attack surface. The last pillar of those challenges, it's the notion of working in silos. When we have different teams or different tools, and teams use one tool and teams use another tool, what's happening is you created this silos environment, okay? And then in a silos environment, everything is going to be more complex to be presented and more complicated to mitigate when it comes up, okay? So what happened? You have a delay on the mitigations. So now that you know what is the modern landscape and just modern current challenges when it comes down to security, you are asking, right, okay, what is my approach to solve this problem? Well, there are obviously many solutions in the market. What I'm going to give you today, in this moment, is the Microsoft solutions. Actually, I'm going to give you one part of that solutions, because the overall solutions is a much broader one. The overall solution is something that we call Defender, Microsoft Defender. Within that big umbrella, we have one product, which is called Microsoft Defender for Cloud, and that is one product that is recommended for solving many of those solutions. Microsoft Defender for Cloud is designed to address exactly the challenges that I actually presented in the previous slide, okay? Microsoft Defender for Cloud delivers and offers a comprehensive protections across a multi-cloud environment. Azure for sure, AWS and GCP. But not only that, if we look into the shift left, it integrates into GitHub, GitLab, Azure ADO, so on and so forth. So Defender for Cloud is the solution when it comes to protecting your cloud infrastructure, your multi-cloud infrastructure, and your cloud-native application. Defender for Cloud has been recognized as one of the highest tier CNAPP solutions. CNAPP stands for Cloud Native Application Protection Platform. It's not a product. It's basically a term. It's a term that was coined by Gartner about a couple years ago, okay? Within this context of a CNAPP, Microsoft plays the main role by providing full security visibility, full security insights, by unifying the security across the entire life cycle of an application. you can see Defender for Cloud in three main areas: the left, the middle, and the right. On the left, basically, you have the notion of shifting left, right? How can I protect my modern applications if I don't protect the code right from the beginning? I cannot wait the end. It's too late. Or I should say it's heavily more expensive to try to protect once it's productions. So what I do, I need to start right from the beginning. And that's what Microsoft Defender for Cloud provides you. That's what you're going to see in the next demo with James. By integrating with the GitLab, GitHub, and Azure DO, specifically by integrating with the GitHub Advanced Security, okay, also known as GAS, we provide the organization, the developer, the tool to see what's wrong in their code, what's wrong in the package associated with that code. Okay? By embedding those insights right from the beginning and continually embed those insights in the pipeline. Because, you know, I can scan the code when it's in the repo for secrets, for vulnerabilities and so on, but then I have to scan once it's a pipeline because eventually that piece of code needs to be implemented, deployed at the runtime. So with Defender for Cloud, you have that options to embed it, the proper security gates while you're shipping that code from the repo into an environment which is a live environment. Okay? So now you have a solutions where you have a visibility into the early stage of your applications. You can protect this application. You can, you can ensure that the application does not go to the next stage if it does not meet all the security control that you are putting in places, okay? Then the application gets in production. Fine. Once it's production, then the application offers its use. And then with time, alerts still going to be generated. The recommendation going to be generated. Basically, security insights, security telemetry are going to be generated, okay? To the point where you obviously going to have a large amount of insights that you need to deal on a daily basis. And then everybody knows that IT, security, devs, it's always the smallest team in many of the company, unless you are, an SV, you actually, do that for a living. But in any organization, those teams are small, so the manpower is short, right? So what's important here is the fact that you want to reduce their alert fatigue. Knowing everything is a great thing, but then if you cannot mitigate it in a smart way, it's just you're going to stay behind. It doesn't matter how much data that you're going to be presented, you're always running behind it. Believe me what I say, there are companies, organizations out here that still have workloads or resources that they are vulnerable to exploit discovered 2, 3 years ago. If I'm an attacker, if I'm a hacker, and I do an assessment and I discover of a company and I see something that is known from 2 years, guess what? 2 things. This company doesn't have enough manpower to fix anything. This company maybe doesn't care about fixing it, okay? And maybe because their workload is not important, fine. But this company does not even know, doesn't have a proper tool. What I do, very quickly, I'm going to attack this company because I'm going to get an easy way in. And from that easy way in, I'm confident that this company has more vulnerabilities in there. If they 2, 3 years old, the vulnerability is not being patched, guess what? They're going to have more of those, right? Now, when you have those insights, okay, you need to make sure that you mitigate it. So the next thing is, I need to make sure that I can mitigate what's important, it is important to me. And then what it is, this concept is prioritization. Very simple. I have 1,000 security recommendation, 1,000 alert, where am I going to start it from? You want to start from somewhere. You got to be able to create the top-down list, the priority. Defender for Cloud will do that. Defender for Cloud has an algorithm that does not only checks for checks for healthy, non-healthy, when it comes to the security control. It goes far behind. It checks if the resource is important in terms of business value. It checks risk factors. And based on those additional checks, it's able to provide a risk level that obviously gives you the additional piece of data to create the list. So now that I gave you a very quick run of the modern landscape, the challenges, and the solutions, let me put all those things together by showing something very common, an attack path. On the screen over here, you have a picture of a public exposed or public accessible resource. We call internet exposed resource. What is exposed is an applications, a containerized applications. Now, you're thinking like, okay, these applications are running a service that will require public access for our customers to get in and use it. So it is something legit, all right? But what we don't know that this container images has vulnerabilities, known vulnerabilities. Now you have two things. You have something very simple, internet exposure, coupled, put together with the fact that this resource is also vulnerable to some exploitation, and you have something more to be worried. So what's happening now? If that exploit is being leveraged, if that exploit, that vulnerability is being exploited by an attacker, that attacker has access and control of that application. What does he do? He's going to try to know as much as possible to move laterally, right? Soon he gets on, the next thing, whoa, he find out, or she find out, whatever is the attacker, that service running as a container also has a managed identity. A managed identity that was mistakenly configured with too much permissions. Permission that would allow the actual service to access a data store, in this case, a storage account. So the attacker, what does it do? Will move laterally. And with that identity, boop, catch that data inside of this data store, the storage account. And he's happy. Guess why? He finds sensitive data on it already. He's so happy that he found some very good secrets. On top of that, he finds out that in that storage, there are also grounding data for the AI. So what he says, I'm going to poison the data. I'm not going to care stealing the data. I'm going to poison the data. I'm going to get the private sensitive data, but I'm going to poison the data. This is not a fiction. This is a true cases. What I'm trying to say is, those are stuff that we have to be worried on daily basis. And then a solution like a Microsoft Defender for Cloud will provide you the platform to secure preventively, proactively your environment and proactively know those weaknesses before they can even breach us. And now, I want to allow my colleague, James, my colleague James, to do one of the coolest demo, and you're going to love it, guarantee. James, please.
All right, thank you so much. My name is P Brotsos. I am a principal product manager at Microsoft. I'm going to need like a Red Bull and vodka to match that passion right there. I didn't know you were going to get a presentation and kind of a dance there, too. That was pretty nice. My focus is on DevOps security, and what that really is about finding vulnerabilities inside code, shifting left, finding the most critical vulnerabilities in that code as well. I feel I'm pretty highly qualified for this because as a former developer, I definitely introduced a bunch of vulnerabilities in my code before. This demo is really geared more towards the security engineer, either being a cloud security engineer or application security engineer. You might be in DevOps. You might be a developer. I see someone wearing a GitHub swag. This will actually go into a little bit of the developer experience as well. I took a phased approach for this best practice presentation. The best practice is really trying to enable security at all stages of the software development lifecycle, from code to the build to staging, all the way to runtime. With this phased approach, I really feel like you can go as fast as you want or as slow as you want. I put this together over the years of talking to customers and trying to help them build out their security program and making sure that it's just not a posture, but actually developers are actually working and fixing on this. So the demo you'll see is in the Azure portal. I don't want to think or assume you know what the Azure portal is. So this is really where, inside Microsoft Defender for Cloud, where the cloud security engineer resides. I do see application security engineers going in here, but really when it comes down to it, developers should never enter this portal. I talked to a customer maybe last week. They tried to have their developers log in. They had permission issues. They ended up asking more questions on how to navigate the portal in itself. The idea here is the engineer, the security engineer, can help prioritize and find critical vulnerabilities and then give it back to the developer inside their own ecosystem. Right? We want to automate this and have an easy remediation advice. So I'll walk through the Defender for DevOps Security Blade, which is where the code posture is at. And I'll also walk through how you can enable agentless scanning to help increase your awareness. I'll show you how to gate, which is going to prevent the actual deployment of vulnerable containers. And I'll show you our new code to runtime experience, which also helps you prioritize critical vulnerabilities. I was watching a talk yesterday with the VP of GitHub and Marcelo, and he brought something up that I always preach. I really believe developers want to have secure code. They want to fix vulnerabilities. They don't want to get caught in false positives and vulnerabilities that don't really affect the application. So we have to make sure that they're getting the most critical vulnerabilities and the most critical applications. All right. So I'm going to go through this again through phases. There's 7 different phases. The first phase I want to say is to aggregate your results. This is really the first stage of onboarding your repositories by creating a connection to either your GitHub, your GitLab, or your Azure DevOps repositories. This is going to bring in the already existing results. Okay, so you're going to get aggregation of all these results inside one place. This is the first stage. Really, if you don't know what's out there, that's the first problem, right? So this has you don't impact the pipeline whatsoever. You just make a connection to repos and pulling it in. You also notice here for phase 2, it's starting to review the GAS scans. So you can see here that we pull in and we can actually determine if these repositories are scanning using CodeQL, which is the stack analysis tool that GitHub provides, the Dependabot, which is looking for open source packages with vulnerabilities inside these packages, and also secrets. I think you gain a lot of things here. It might be potential someone turned it off for whatever reason, but without having that security enabled, you're already losing a big piece of the puzzle. All right. So now we've kind of gone through the first phases. We brought in all the results. We've kind of looked at these results. So we have an idea of what's going on, just barely. High level, we know how many code findings there are, how many secrets there might be. So let's add in a little bit more intelligence here. So what I'm going to do here is I'm going to enable agentless scanning. And what agentless scanning is going to do is that it's going to scan outside the pipeline, inside of our environment. So again, we're not actually injecting anything in your pipeline. We're not causing any work for your developers or for your DevOps team. We're actually just going to enable these scanners to help us give us a little bit more intelligence. So we have scanners that can look at JavaScript and TypeScript code or Python, really your front-end code looking for security vulnerabilities coming in from the input, right? So using the static analysis, we'll be able to determine things like injection. We can also enable infrastructure code scanning, right? So we want to look for misconfigurations and secrets at the coding stage instead of when it's being deployed. And lastly, you can also, if you don't have GAS dependent bot enabled, we can also enable some more open source dependencies looking for vulnerabilities. All right, so now that we've kind of brought in some more results, we can move on to phase 4, which is understanding your risks. Okay, so now we have an idea of all of the vulnerabilities. We have some findings here. We'll have a health score per repositories. Now we can start ranking these and start investigating them even more. What's great about this is that really kind of narrows down an issue that our customers have when we have these silos, right? We have this cloud security, and we have the developers. Sometimes the cloud security has no idea who to contact inside of the development organization, right? So we point directly to the owner or suggested owner of who these repositories might belong to. We give you some tools and information on how you can actually debug even more. And actually, if you're an application security engineer, it's very useful to be able to go in and actually see the line of code that's actually introducing this and the link right into GitHub so you can investigate it even more. OK, now we have a good understanding on the shift left side of it. Now let's talk about some of the shield right part of this now. So let's go to phase 5, which is preventing risky containers from being actually deployed. Okay, so we have the ability at this stage to scan containers at the registry level and at the runtime level. And what's great about this is that if you have it in a JFrog or inside of Azure registry, we can actually scan these containers and identify vulnerabilities at that stage. And if we do find something that's critical, we might actually want to gate it or block it. Now, if you don't feel comfortable at that stage of going in a complete deny mode, you also have the ability to audit, which will also make just a recommendation or an alert for you. But this is really the first step of being more compliant or having, having some kind of gating in place so you don't actually deploy these vulnerable containers. So as you create these policies, it's easily set up that whenever you run whenever you deploy your pods and your Kubernetes, that'll actually block the deployment right at the command line. Right? So it'll actually tell you exactly that you have some kind of policy violation that will allow you to investigate further and reject what's being pushed. You could go in a little bit deeper and see other policies that you might have set. And you can kind of do it by the image and also see the images that were actually violated the policy. All right. So to me, the next phase, which is phase 6, is one of the most important ones. And this is when we can prioritize using code to cloud. So you get all of these recommendations from containers, from other parts of deployments of your IAC. But you have really no idea on the context behind it. So one thing I truly believe is prioritizing these by a couple different factors. One thing I think is very critical, especially in the very beginning, is looking at attack paths that go from the internet exposed to some kind of sensitive data. Right? You have some kind of storage account that has critical information that might be yours or even your customers, even in a worst case, of credit card numbers and social security numbers, or any kind of privacy data. So we can focus on these type of attack paths and really reduce the amount of noise. And that's key, right? People are just overwhelmed with the amount of results, so let's focus on the most critical vulnerabilities and the most critical assets. So we've just introduced the ability to see from code to build to ship to runtime. And why is this so cool is that I can actually trace a runtime container right back to the repository that built it. That is so powerful, and be able to look at not only the vulnerabilities that are inside that container coming from third-party packages, but also look at the code that's building building the app that runs on the container itself. And this is also solving another problem where, again, what I mentioned before about how your cloud security architect or engineer has no idea who to talk to on the engineering team. We've introduced this new GAS integration that allows you to create a GitHub issue directly to the developer. I'm going to take it actually one step further than that. So I've been working in application security for about 10 years now. And this is nothing new where you can see the vulnerabilities inside of a pull request. But what you are seeing new here is the runtime risk factors. Developers have a really good idea right now if you have sensitive data, if it's internet exposed, and they have a reason to actually go in and take a look at it and investigate it. But with our new integration with Copilot, you can actually assign it to agentic AI as well, and have the agent go in and discover where the vulnerability is, and be able to fix it itself. Right? So there's 4 CVEs that are identified here, and it's coming from a package called BusyBox. Now, BusyBox is not a direct dependency. It comes from the supply chain. So now we're going to trace it up. We don't know necessarily where it came from, but using this Copilot and using it and assigning it to the agent, it identifies that, hey, actually it's coming from the base package. I have to update from a Node 14 package to a Node 20 package. And if I do this, it's going to fix 4 critical CVEs at the same time. So it's really amazing how you can kind of step into it. I kind of went a little bit fast through it, but you can actually step in and actually see the conversation between it and on how it actually was decided to make that decision. So this is a big announcement that came out this week at Ignite. So at that stage, if you're a developer, you can go in now and you can actually merge this. You have more context, and you actually have the agent that actually made the fix for you. And as a cloud engineer, you can actually, or a security engineer, you can actually see the status here, and you can see if it's actually been worked on or not, or if it's still being processed. Because then you have to go in and track down where the status of it has been fixed. We'll actually update it here as well. So you notice in this code to cloud runtime diagram that I do have, that I'm missing the build stage as well. So I did that on purpose for this demo. And it kind of leads on to the last phase, which is shift container scanning to the left. Okay, so what we saw here is that we had a security engineer, go in and triage a runtime vulnerability in a critical path. But what if we can do that at the development stage? Okay, so I'm going to walk in and show you how we can enable container scanning at the pipeline level, which is also a feature that came to public preview during Ignite as well. So in a pipeline flow in GitHub Actions, so if you're not familiar with GitHub Actions, it's basically GitHub's CI/CD pipeline process. And what it can do is it can be evoked on specific events, and typically it's done on a pull request or a push event. So during a push event here, or a pull request, I'm doing a build of a Docker image. Very, very simple build of a Docker image before I actually deploy it to my Azure Container Registry. You can see here that I just add in 2 simple lines of downloading our Defender for Cloud CLI and then executing it on that built image. So if I do this in the pipeline stage, I have the ability, and then I run just a simple serif command to parse the serif file that was produced. It will actually create alerts inside the code scanning. And it's using the same technology, the same tool as being run on the container registry. So it's going to be matched. It's going to be mapped directly to each other. Okay? So if I find this at that level, the engine that it's run is called MDVM, but you can think of it as a container security tool. And you can see that in here I have produced MDVM results, And you can actually go in here and filter through it and work with it as a developer normally works with any other security tool, right? So they're not leaving the going to MVC. They're getting everything directly within GitHub and be able to triage it, be able to investigate it, be able to see some remediation advice as well. Another cool thing that we do is that we we could decorate the pull request. So to me, this is the best injection to show where, to show developers what they've done in the pull request. It's an automated tool that gets run at the pull request level. You can't merge it until it's finished. And it gives you a summary of the results and also can show you what you've introduced new into that pull request. It's not giving you a huge technical debt. It's not going to show you everything from the last 2 years. It's going to show what you directly are actually pushing at this time. OK. Where's the clicker at? So just to kind of conclude on this, on the phase approach on the demo. So what we did was we discovered all the repositories, and we got a posture of the application code. We were finding applications, early, before they were built, and we're blocking risky containers from being deployed. We were able to trace all the way from code to the build, to the ship, to runtime, and we gave developers remediation advice right within their tools. All right. So the beauty of this phase approach, I believe, is that you can accelerate this as fast as you want or as slow as you want as you gain trust into it. Some challenges that it solves is that you can now really understand what we consider to be the riskiest repositories. Now you can figure out who is actually the owner of these repositories and who you can contact. And again, it blocks vulnerable containers from being deployed if you have that for compliance. And it really solves shifting left of giving those developers results directly inside their pull requests. All right, so some key takeaways from this session today. So first, many developer environments still do not have enough visibility into security risks. When we can't see the risks, it becomes hard to find and fix those issues that matter most. Second, attacks are growing, both in number and in complexity. This means we need to stay alert and keep improving our security every single day. Third, security teams often work in separate groups. When teams do not share the information, it slows everybody down and makes problems harder to solve. But the good news is that tools like Microsoft Defender for Cloud, using AI, working closely with GitHub, really helps teams fix those issues faster and helps teams spot those issues as well. And we have guardrails and command line interface that helps just to make sure that the secures code before it actually moves on. I want to take a moment real quick to highlight a very important announcement that we had this year. So at Microsoft, we understand how hard cloud security can be. Many tools and teams work in silos, which lead to gaps in visibility and slow workflows. We also know that threats don't stay in one place. A single threat can touch your cloud, your identities, your endpoints, your entire digital estate. If you can't see that full picture, you're not fully protected. And on top of that, more organizations than ever are using multi-cloud and hybrid setups. Your environments are growing fast, and we want you to meet you where you are on this journey. So to help all of this, we are expanding our Microsoft Defender for Cloud's posture features into Defender Portal. Okay, so your security teams will now see one unified cloud security dashboard. This brings together posture management and threat protection all in one place. So what you saw today was going through the Azure portal. And let me be clear, that will not change. This portal will still be there, and you can still live in this portal. But now we've offered to have an experience enhanced and having this Defender portal released. And finally, I'd like to conclude with this. Many organizations today are starting to see the value of having one unified security platform, one that works smoothly across multiple clouds. So AWS, GCP, Azure. This is not just for Azure. This is for all clouds, right? And multiple pipelines, and protects them before attacks happen and while things are running. So proactive security is about finding and fix risks early, before they turn into a bigger problem. This includes tools like Cloud Security Posture Management and AI-driven risk fixes that help teams strengthen their security posture faster. But runtime protection is just as important. This is where we detect and respond to threats in real time, whether they're hitting APIs, servers, or containers. The fact that we support both agent-based and agentless protection means teams can choose what fits their setup best. I have some additional resources. I'm not sure how we're going to share this, to be honest with you, but we'll have the ability, hopefully, you'll be able to hopefully get this online somehow. All right, for Giulio, thank you so much for your session.
Thank you, guys. Told you it was a cool demo.
Yes.
About what?
Yeah. So this demo is very catered towards the GAS integration, and that is our first integration. We are doing Azure next. So you'll be able to have that same Copilot experience through Azure using, it's called GASDO. But yeah, the first release was for just GAS alone. But what you saw for the pipeline, that's just a CLI tool. You can put into Azure pipelines as well to detect container scanning. But the only thing that was different was that code to runtime stage where you actually create the issue. That's only being done through GAS right now.
So when the developers are writing the code, we do some scanning and bad time itself to be more proactive. How does Defender, will that enable something like that?
So you can do a couple different ways, right? So one is if you have GAS enabled, it will scan, while you do your pull requests and your push events, right? But also, if you have the CLI, that will also scan as well, which is enabling all those tools that you saw, which is the misconfiguration, the misconfigurations using the IX scanner, the container scanner, and then you can evaluate at that. And if developers, for whatever reason, they ignore it, push it, those results still get pushed into MVC. So you can see it all in one place, one aggregated view. Okay, but the idea is that we want to give those back to developers, right, by showing them in the pull request, and eventually, having an idea of having a full end of workflow where it gets assigned as an issue or some kind of alert. We're also working on policies where, policies will be evaluated at the code level and be able to give those results back to developers as well.
Yeah, I think the code security is coming in the future, right?
The code security is here now.
Oh, it's here.
It's here now. That's what you saw. It's called Defender for DevOps Security. That's our code security.
Yeah, it's part of the Defender's SPM as well.
Okay. And anything you have for scanning and finding vulnerabilities in open source components?
Yeah, so you can either use the Dependabot, which is part of the GAS, or you can use, we have an open source scanner that will also do that as well, either at the CLI or at the agentless mode as well.
Okay. And last question, anything for secret scanning someone afterwards?
Yeah, it's included.
Yeah, so you can see that we're in private preview for that right now.
Okay.
So that's going to be coming out, I think, probably at RSA. But everything you saw today is public. It's not roadmap. Everything is part of it.